Hello, welcome everyone. This is Karthik and team to present the bootcamp for day one of Chaos Carnival today. I hope you have been enjoying all the sessions all along, and there are some interesting sessions coming up in the second half as well. So do stay tuned. While you are hopping booths and taking a break, we thought this is a good opportunity to conduct a quick boot camp on how you can ease yourselves into chaos engineering. This boot camp is going to cover mostly things around how you can set up Litmus Chaos framework for chaos engineering, how you can construct simple experiments and run them. And the main focus will be around running a use case, a chaos use case on Kafka. So we will be doing a broker pod delete experiment, and we'll see what is the process of doing this chaos experiment, how to validate the hypothesis, how to construct an experiment custom resource, and how to execute that from the Litmus portal. All right, so with that, let me share my screen. I hope my screen is visible. All right, so we have got a very simple agenda. So we'll do a quick Litmus Chaos installation run through, and we'll look at how to construct a simple chaos experiment and run it using the portal. Then we'll do a quick refresher on Kafka for folks who have not installed, set up, or used Kafka before. And we'll discuss today's actual chaos scenario and demonstrate that. So once we are done with all these items, we have an optional hands-on lab that will run for around 30 minutes, where you will get some prepackaged environments where all the important prerequisites are installed, and you can go ahead and just execute the chaos to see how it really works. So with that, let's take a look at the Litmus Chaos installation run through. I'm assuming that you don't really have much to be told to regarding what is chaos engineering, why it is important, what is the Litmus project about, etc., because you have been hearing all that in the previous sessions. So in case you need any answers on some of these questions, and if you feel that there is something that's not very clear during this bootcamp or during this demo or tutorial, do stop us. I'm Karthik, one of the maintainers of the Litmus Chaos project, and I am also an architect at MyData, and I am joined by Shubham, Udit, and we also have Om here, who are also part of the bootcamp team, and we will be executing the experiments together for you today. So in case there are any questions you have, please feel free to ask them, and you can raise your hand on the AirMeet platform, and we will bring you on stage to ask those questions and probably carry out the discussions as we go. So with that, let's get started with the installation steps. So I have a cluster here in which I don't have any pods in the Litmus namespace. In fact, I don't have the Litmus namespace installed at all. So you can see that I've just got a few other namespaces here. And you can also see that I have an Nginx pod that's running in the default namespace. So this is the setup that we have. And how do I go ahead and run Litmus? The installation step is pretty simple. We're going to be doing a portal-driven approach of doing Chaos experiment execution. You can directly create the Chaos Engine resources, but we will be doing it via the portal. The installation step for the portal is very simple. So I've got a K-test manifest for it, which I'm going to apply. So this is going to create the Litmus namespace, and it's also going to create the control plane pods that are necessary for doing the orchestration of the chaos workflows. So in Litmus, you have the chaos experiments and the chaos engines, which are essentially the chaos resources or the CRs describing what you want to run and how you want to run. A very brief explanation of that is available here in case you'd like to take a look at it. Chaos experiment is a granular definition of your chaos intent, where you specify the image that runs the experiment, the chaos library that's being used, what permissions are necessary for running an experiment, and what are the low-level chaos parameters themselves, how long you want to run it, or what are the basic prerequisites that you need mandatorily to run the experiment. They're all provided in the Chaos Experiment CR. It is available off the shelf in the Chaos Hub, which is an open marketplace for Chaos. You can see this has a lot of categories of experiments. We are going to select a Chaos experiment from the Kafka Chaos category. This is the experiment CR that we're going to pick. And the other resource is the Chaos Engine, which is what you might mostly be playing with or helping construct or modifying, which is where you tell how to run the experiment and on what target to run the experiment. So what is the application you're going to run this Kafka Chaos experiment on, and what are the run characteristics that you would impose on this particular instance of the Chaos experiment. And schedule and results are other auxiliary CRs, which we will take a look at. The schedule is not part of the demo today. The rest of them are. More importantly, the portal is actually going to help you construct a chaos workflow, which is essentially the unit of execution in the portal. And it's going to combine one or more experiments to give you a real world effect of chaos on your systems. So for now, let us take a look at what's happening on the installation side. I've got this cluster in which the control plane has been installed, that's the portal has been installed. Now I'm going to go and find out what is the endpoint for the Litmus portal. So this is my services. I've got a front-end service available here, and I have exposed it via the node port. I'm just going to try and get the external IP address of this particular one of the nodes, and I'm going to use the port that's available here for the front-end service 31569. And I seem to have made a typo here. This is going to help launch the portal, and I'm running the version of the portal, which is version 1.12.0 that was released last month. There has been changes since to the portal, so you might, if you are running off the master, you might find more changes. I'm just going to provide some user details and project details here. That's just going to help me set up my project. Okay, so let me complete the user setup here. With this, I have set up my project on the portal. As you might be aware, you can run the Litmus portal on one cluster, and you can connect other cluster targets to this portal and execute chaos against it. You will have agents running on the external clusters. In this case, I'm going to run the chaos on the same cluster where I have the portal running. to ease things in the interest of time. So I have got my project here, and I'm looking at the target. In my case, the target is the same cluster, which is where the portal is installed. So when I complete this process of setting up my project and the target, I'm also going to see other pods that have got created here, namely the chaos operator, which is essentially what reconciles the chaos engine resource and carries out the experiment. And I've also got the subscriber and the workflow controller. Workflow controller orchestrates the chaos workflows, and the chaos engines embedded within the workflow are reconciled by the chaos operator, and this is the actual brain behind Litmus. And the subscriber is essentially taking requests from the portal and carrying that out on the an experiment is how you would do it. You have the workflows here, and I'm going to schedule a workflow which is going to do a simple pod delete experiment on the Nginx pod that I have run on the default namespace. So I'm selecting the target cluster against which the chaos is going to be continued. There are some predefined workflows. I'll just show you how you can construct a custom workflow. You can give any name you want for it. You can either upload YAMLs that you might have stored either in Git or you might be having in your local workspace. Or you can also construct experiments using the hub that comes shipped embedded within the Litmus portal. So this hub is the same as the Chaos hub that is available in public, which we saw a couple of minutes back. You can also configure private Chaos hubs in case you have your own experiments that you fed into your repositories. In this case, I'm going to use the public hub. So let me select a simple experiment like a pod delete. I've chosen the namespace where I want to run the experiment in. Now let me select the tunables that I want for running this experiment. I'm going to construct this experiment against the Nginx application, which is in default namespace. It's of kind deployment, and I've set the annotation check to false. It's a value you can set to true if you want to achieve greater isolation and want to control the blast radius in case of multiple applications that share the same labels. If you want to make it unique and lend itself to chaos, you can turn on the annotation check. And I just want to do one iteration of chaos just once. So I have the interval and duration as the same. And with this information, I just add the experiment. I don't want to add any other experiments. You get a workflow like this, which is going to install the experiment CR, run the chaos, and then clean things up. So you can see the chaos engine has been constructed here. And this is the one that's actually doing the pod delete experiment against an Nginx application with the tunables that we set during the chaos selection. With that, I can select some weight for this particular experiment. In case you're selecting multiple experiments and you know that each experiment is of a certain importance, you can set that here. In this case, I just have one experiment. I give it all the importance and I set the weight to 10 points. This aids the calculation of a resilience score that's calculated against a workflow, which is a weighted ratio of the success of your workflow. Total success experiments versus the total experiments. In this case, I just have one, so I'm going to schedule it immediately. I don't want to repeat it. And you can see, you can verify the YAML if you want once again, or you can just finish it. You can go to this workflow and look at the execution. The installation of the experiment CR is going to take place first, followed by the execution of the pod delete experiment. And that is going to be reflected here. The status is going to be viewed here. And you will be able to see shortly the Nginx pod getting deleted. So I have some pods that are going to get created here. These are transient pods that are going to execute certain steps that were defined as part of the workflow, such as installation of the experiment, CR, execution of the experiment itself, and cleanup. So all of them is going to be performed by individual pods like this. You can notice the runner for the pod delete experiment here. This is actually killing the Nginx pod like we intended it. And then finally, it's going to remove the chaos engine. So running an experiment using Litmus is as simple as this. You just need to set up the portal, and you need to select your application, select the experiment, provide your tunables, and just run the workflow. And there are a lot of workflows that you will see. You can find a lot of predefined workflows that comes shipped along with the Litmus portal. So you can use that if those make sense, or you can construct your own workflows. So we will see this ending in a few seconds. So with this, I just want to check if there are any questions that I can take about the general chaos injection procedure within Litmus, chaos experimentation procedure within Litmus. If things are okay, we will go to the actual agenda for the Kafka demo on AWS today. Are there any questions? Yeah, there is a question from Alexander. What would happen if the experiment execution, the pod will, or what will happen if during the experiment execution, the pod will crash or will be removed by kube? What about rollback? That's a great question, Alexander. So in cases where the Kubernetes itself is injecting some undesired chaos into the system, then in that case, the experiment is designed to check before each pod delete iteration, and after each iteration, before it starts the next one, it is designed to check whether the target under question is an optimal state. It is in the right state for executing further chaos. If it is not recovered within a desired period of time, and you can tune the timeouts for how long you want to wait before it returns to optimal state. If it does not return, then the experiment is deemed a failure and you cannot proceed with the chaos. You're blocked. And in cases where the pods are in good state, the next iteration of chaos is going to continue. By default, the experiments are designed to roll back whatever injection they have carried out. In case of pod delete experiments, the targets mostly are workloads. One of the differentiators in Litmus is the fact that the chaos engines are created against Kubernetes workloads like deployments or stateful sets or daemon sets. So the recovery of the pod is naturally taken care of by Kubernetes. In case of experiments which inject these failures at a lower level, let's say at a container level, you're basically trying to inject some kind of network loss or latencies into the network namespace of the containers. The experiment actually reverts the change before ending. So you will be able to get to the same state that you started the experiment with, that was there before you started the experiment. So the rollbacks are guaranteed, and it also supports abort. And let's say for some reason you felt the situation was getting out of hand, or you really want to abort chaos because you see that there are some other downstream applications which probably are not behaving the way you want them to, then you can abort the chaos, and that's going to remove all the chaos processes that it has injected, depending on what experiment it is. So I hope that answers the question. Yeah, there's another question by Darren. What about Litmus service accounts for an experiment? We were using Litmus admin in this test. That's right. We were using administrator mode. You're right, Darren. That's just for simplicity of the demo. You can choose a different service account as well. Each service account is described in the Chaos Hub for the experiments. For example, we're talking about the pod delete chaos experiment, which we just did. And you can see that this has its own RBAC So one of the things in Litmus is it will enable you to create the experiments with service account that have permissions to do just what is sufficient. You can actually check that a pod delete experiment needs these permissions. You can actually refer to the recommended service accounts that are shipped on the hub for the individual experiments. In case you are having autonomy on the cluster and want an all-encompassing service account to perform several experiments, you could use a superset like we just did with the Litmus portal execution, or you can use the service accounts that are recommended here. All right, there are some great questions. Before we take more questions, and we will definitely take more questions as we go along, I'd just like to introduce you to the agenda of the Kafka experiment. So we are done with the installation run through. I hope this was a simple exercise and it was clear to you. We will do a very quick Kafka refresher and discuss the chaos scenario. And I'll also discuss the setup that we are going to do this particular experiment on. It's a different one to the cluster that we've used here. So I'm just going to close that right now. And also this cluster, this portal. I'll move on to another cluster where, in the interest of time, we've set up a few more things like Kafka and Litmus portal already. So we'll just run the workflow. Yeah, so here is a very quick Kafka refresher. I'm sure there are more folks here who are experts on Kafka. We are doing this for illustration of the chaos capabilities, application chaos capabilities within Litmus. So Kafka is really the go-to solution today for creating data pipelines, and applications generally publish messages via records to a Kafka node, which are called as brokers, and these are passed to the consumers, which are generally the ones that are processing these records or messages, and these messages are stored or transmitted as topics, and each topic is broken down into partitions for better performance and scalability. Most of these partitions are generally replicated. You create topics with replication, and they are assigned to what are called as leader brokers. There are partition leaders, which are mostly owning the right processes, etc. And there are follower brokers. There are in-sync replicas, the replicas that are actually replicating the changes and ensuring high availability. Then there are controller brokers within the same set of brokers that you have on the Kafka cluster, which carry out a larger set of administrative tasks. And the state of Kafka is generally stored in Zookeeper. This is generally a very, very quick summary, which is also illustrated in this schematic here. So you have the producers and consumers, and you have the brokers that are carrying out the topics, and the state being maintained in Zookeeper. So what we'll do today is we will basically test the deployment sanity of a Kafka cluster on Kubernetes. So I have a Kafka cluster here that you can see. Here is a Kafka cluster. We have installed it using a popular operator framework from D2IQ called as Kudo. And this is the Kafka that we've installed along with Zookeeper. And I also have an exporter here, which is trying to get some metrics from this Kafka installation. Now, the intention for us is to test the deployment sanity of the Kafka cluster here. And to do that, we will set up a liveness message stream. We will create a producer-consumer container pair, and we will set up a message timeout in the experiment and run the liveness message stream, and then run the experiment to identify the partition leader and kill it. When we kill that particular pod, we want to see if the liveness stream runs uninterrupted or whether it actually breaks, which implicitly means whether the message timeout that we are setting at the consumer side is appropriate or no. And if it is taking a long amount of time, if it has an inordinately high timeout, then that means there's something needed to be changed within the infrastructure or the deployment to improve the cluster. It's a very simple case. And the health check that we are going to do is we are going to verify the available broker list. And we're going to get this information from the Kafka exporter. You can see that I have a Grafana dashboard, which is showing the broker count and the partition. So we will see that the requirement for the experiment is to have the number of brokers maintained at this number before and after the experiment. All right. So this is what I have for my cluster. And the tools that we're going to do, of course, are the Chaos experiment chart for Kafka and the Litmus portal. So let me see if we have any questions regarding the Kafka setup that we have before we delve into the
Sorry to interrupt.
experiment.
Actually, the screen is not visible. Shared screen from last 5 seconds.
Okay, I think. Okay, did we get a chance to look at the Grafana dashboard?
Yeah, from here.
Okay, so yeah, we have the broker count being tracked. I have set up a dashboard for that, and we are going to do a health check. That's basically going to see whether the broker count is maintained by the time we end the experiment. And we're going to use the portal to do this experiment, and the Kafka experiment chart, like we saw a few seconds back, is available right here. So you can take a look at the Kafka experiments from here. All right. So with that information, I just like to introduce you to the Bootcamp's repository in Chaos Carnival org. In case you are interested in running this particular experiment in your own clusters, you can actually follow the steps that have been mentioned here. Most of the resources for setting up Kafka, the monitoring piece, as well as the Litmus portal are all available here. The hypothesis, like we mentioned, is here. We are going to kill one of the leader partition leader brokers, and the expectation is for the other brokers to take over as the partition leader and continue. And all this happens in enough time, in fast enough for the message timeout to not be exceeded at the consumer side. And to this effect, to this end, the experiment creates a topic along with a producer-consumer container pair and verifies successful message stream. The steady state hypothesis is very simple. In this case, it's very minimal. We're just going to see if all the brokers are alive and the message queue is active. And I'll just describe as we run the experiment how this is validated. With this, let me actually, and the documentation for this is also available here in case you'd like to take a look. It's there in the Litmus doc in the Kafka broker pod failure experiment. All right, so let me go ahead and schedule the workflow. I'm going to connect the same cluster where the portal is installed, like we saw during the installation case. I'm going to create my own workflow. And in this case, I'm going to upload a custom workflow YAML that I have created. So I'm going to upload that file here, and that's available in my workspace. And this is how it's going to look. It has a step to install the experiment CR, then perform the actual chaos via the chaos engine, and then it just reverts it. If you take a look at the chaos engine, for this particular experiment, you can see that I've targeted the Kafka application, which is of the stateful set kind. I'm using the Litmus admin service account. And I have a replication factor of 3 for my partitions. And I have given all the details of my Kafka application, as in what is the service name, what's the port, what is a sample consumer timeout that I want to play with in my experiment iterations, and what is the zookeeper details. And I'm just running one case or one instance, one time delete of the Kafka broker pod. So we'll identify the deleted partition and kill it. If I run this experiment for a larger duration with this interval, let's say 30 seconds versus an interval of 10 seconds, we're going to identify the leader each time to whichever it has switched to, and then we're going to kill that particular broker, and then we're going to run the liveness stream. You can run this experiment without the liveness stream as well, in case you have your own topics already running. So in this case, since we are simulating it, we're just enabling this. So this is the Chaos engine, and there are some auxiliary properties here, such as monitoring needs to be true for me to identify the chaos events and superimpose them on my Grafana dashboard for my application, which is what we call as chaos interleaving. And for that purpose, the monitoring has been enabled. I'd like to retain my pods after the experiment just to see the logs. You can choose to delete them. And there are a host of other additions you can make to this engine spec about how you want the experiments to run and how you want the chaos resources to be like, which you can find inside the concepts page where the schema has been defined in detail. So in the interest of time, we'll just go ahead with this particular workflow. Again, this being a single experiment, I'm giving it all the weight associated. And I'm going to schedule it now. And let me go to the workflow. You can see the workflow is begun. And you can see what's happening here by actually taking a look at the cluster here. So this is the cluster against which we are running the experiment, and the Arco pods are going to be created to launch the experiment CR, install the experiment CR, and proceed. And I have also got the Kafka cluster here. I have watched the pods, the Kafka pods. And I've also kept a command here ready to run to see how my consumer behaves. The messages on the consumer are available or no. Is my message stream all right or no is something that I'm going to find out here. Let me take a look at what's happening here. Okay, it has installed the experiment and it's starting. Okay, I think I've lost connectivity here. Never mind. Okay, I've lost my connectivity on my cluster, so I seek pardon. Just give me a second so that I can reconnect that. Meanwhile, the experiment is in progress. All right. Should be able to bring this up real quick. All right. Okay. So I have my cluster back. Let me share my screen once again. Okay. Just to see what has transpired on the experiment here. I'm just going to get pods against the Litmus namespace. We will see some of these pods that have actually got created, and they are right now in progress. The Kafka broker pod experiment is in progress. And if you look at what's happening to the Kafka experiment themselves, the Kafka pods themselves, you can see that the leader broker has been killed, and it has just come up once again. It's a couple of minutes since it has been reset and brought back. And the liveness, which was actually running at this point of time, has actually been completed. The experiment has been completed. So since we were not able to catch it, let me run it once again. But before that, I just want to show you what has happened during the experiment period. So you can see the broker count has actually remained, the health has remained all right, and the partition replicas have remained. And the experiment status can be checked using the Chaos engine, which we are running on the Litmus namespace. Okay, so we have got a revert chaos step which has actually happened and remove the experiment. So let's go ahead and run the experiment once again. It has actually completed, but I think we just lost the experiment execution because we had the network disconnected. So we had some real world chaos happen during the demonstration. You can take a look at the chaos result as well. It's holding information of what actually happened. So it said it passed. So we were able to see the liveness message stream unbroken. We've had a couple of passed runs. That's what the history is saying. But let me go ahead and run the same experiment once again. And for that, we'll just let me run both commands that are useful to see what's happening during the chaos execution. This is what's happening to Kafka. And I'm going to click the command available for checking the message stream. To Kafka consumer. It's going to be a hash here. Let me rerun the same experiment once again. So let me schedule a workflow on the self cluster. We'll run it with a different name. Let's say Kafka Chaos. And we'll upload the same workflow YAML here. We've taken a look at this spec already. So let me go ahead and schedule it right now. All right, so this time, let's see what happens. Meanwhile, as this happens, let me also try to explain or highlight the analytics section. So each of these experiments or the workflows that you've run carry a resilience score against it, which I mentioned is the weighted ratio of successful experiment versus the total experiments against their weights. So you can actually see that information here for individual workflows, and you will get some kind of a graph for the period that you want, for how long the experiment has run, how well the experiment has succeeded over a period of time. You might be running these experiments against different releases or different builds, and you want to see how your application is behaving. each time. So that is something that you can find out using that. So let me actually take a look at the Kafka liveness stream here. So it's a very simple stream. The producer is just printing a string along with the timestamp, and it is expected to reflect on the consumer with a very small latency of a second or two. And we are terminating the reader here. It just got terminated, as you can see, but the message stream was not broken, which actually indicates that the timeout that we've used during this experiment is probably all right. We have used a consumer timeout, which is good enough for this cluster. But if you need shorter timeouts, then you can play around with it, see whether this really holds. And how do you find out that? That's something that you can find out. There are some results that you can see. We've got success as well as failure results in the bootcamp repo. An example of a failure looks something like this, where the consumer fails, the message stream actually breaks, and the timeout has been exceeded. And this results in the experiment being set to fail. You will get a failure, a chaos result, and you can actually create probes within the chaos experiments to verify other aspects. Let's say you have other applications depending upon Kafka, and you want to find out how they have been doing when you're running the experiments. That's something you can include inside of your chaos experiments. And for the success case, your experiment pod looks something like this. Implicitly, you check for the status of Zookeeper as well as Kafka, as well as the liveness pod as it runs. And if everything is good, the experiment is deemed successful. Otherwise, it's set to failed status. So this was a very simple demonstration of what happens when you run the chaos, how you can run it, and what happens when you run them. The interleaved dashboards are like this. You can see the broker actually went down and then immediately came up, and this red portion, which is a Grafana annotation, is actually telling you the Litmus Prometheus metrics, when the experiment actually started, when it ended, etc., and whether it was successful or no. All that information can be provided, are provided by Litmus, and you can use that to achieve some chaos interleaved app dashboards like this. And you can actually go ahead and explore the manifests or the artifacts placed inside the bootcamp repo. The chaos engine, you can see, has a lot of events against it. These are all the chaos events that get generated during each stage of the experiment. When the chaos engine is initialized, when the experiment jobs are created, in the pre and post chaos checks, the health checks are executed, and what happens to the summary, etc. So this is to aid the observability as you run your experiments. With some increased and more complicated hypothesis against steady state can be placed using Litmus probes, where you can say, I want to check other conditions as I run the experiment. And these probes can run in parallel with the experiment to see what's happening during the chaos injection. So this was a very quick demonstration. I'd like to take some questions. If there are, okay, there are a lot of questions here. There's a question by Rahul, which says, does the public user have access to the portal that you're using? If not, any other service to implement demonstration? Absolutely. We do have a few view admin users on the Litmus portal that I just used. So you can actually set up some kind of teaming. I've created a team with a view admin, and you can actually navigate the portal to see what we have done. In case you want to run this experiment against a real cluster which already has these components installed, then please reach out to us. We have a few folks here, Shubham, Udit, Om. You can reach out to us. There's also a bootcamp Kafka Slack channel. So you can reach out to us individually, and there are a few prepackaged clusters on a first come, first served basis where we will give you access to a Bastion VM or a harness VM against which, on which you can run the kubectl commands and execute the steps that we just did. So that's one thing. So do reach out on Slack, Rahul. We should be able to help you. Alexander has a question. We defined many environment variables in the workflow. We want to perform another experiment on Kafka that shares most part of this. How would you do it? We don't want copy pasting. That's a great question. You can actually do it by doing this on the portal. Alexander, let me just quickly walk you through that. It's very similar to what we did when we ran the first simple pod delete experiment against Nginx. Let's say I have a cluster, then I select some experiment, say kubeproxy chaos. You will have a predefined workflow for Kafka as well, something that's coming up in future releases of Litmus. And you can actually select this experiment, for example, or you can select your own workflow. Go to the hub here. You can actually have a Kafka broker pod failure experiment, let's say. You can select that from your Chaos hub. And then you can go and modify these environment variables here. If there are new environment variables you want to introduce for some custom experiment you built on top of the existing Kafka experiment, you can add those key values here, and you can construct the eventual workflow instead of having to copy paste them. That's one way you can do it. I hope that answers. The next question is from, okay, I think Raj was answering Alexander about how you can do that through the doc. Orko also has an answer. So Alexander, if you attended the previous session on event-triggered chaos, you might have noticed the discussion about the Litmus CTL, which is essentially a CLI that helps you generate workflows much the same way the portal is helping you generate through this wizard. You can also use the Litmus CTL to generate these workflows, and you can commit them to Git and then add them as a predefined workflow that you basically saw here. All these are predefined workflows, so you can get one of your own through the Litmus CTL as well. So that's something that's coming up. So Rahul, yeah, I think Rajbabu was answering Rahul. There are a few prepackaged clusters, Rahul, so you can reach out. We can share the link with you. And Alexander is responding to Orko. We're copying the workflow and changing data. Is there option to create a common configuration file and load it into the workflow? Yeah, that's the concept of predefined workflows. So you can actually load these predefined workflows, and you can basically select these predefined workflows and even edit them inside like this. So you have this editor, you can load a predefined one and edit. That's one way of doing it. An alternate way of doing it is to construct it via the workflow construction wizard. That's also going to work. So are there any more questions? Was this helpful? Yeah, there's some questions on the session chat as well from Darren. Is there a way to clean or delete the workflow on the first tab or of the portal? Yes. So CRUD operations on workflows, as in deleting workflows from your portal, is something that we are enabling in the subsequent release in 1.13 of Litmus. Right now, you can edit them and you can create them. You can also remove them in the next version. You can also remove not just the workflows, but also manage the removal of and modification of your Chaos hubs from your My Hub field or page on the portal. There's a question from Anujit. Okay, there's feedback. Thanks, Anujit, for the feedback. We're trying to simplify the experience of running Chaos using the Litmus portal. There are more features coming up with respect to how you can define your hypothesis and actually add more experiments in a simple manner to your workflows as well. If you have any other questions and you want to be heard, please raise your hand and we will sort of add you to the stage. We'll be happy to bring you on to the stage and you can have a chat. You can discuss this as well. So that's all we had for the demo or the tutorial. There are very interesting sessions lined up after this that start in another 20 to 25 minutes. So we will be available for some more questions here. And there is an optional hands-on lab. If you would like to run the same experiments and if you'd like some guidance on running them, you can reach out to us. And we'll be happy to help you run that over the next 30 minutes. If you have any questions or in case you want to view the stuff against whatever we just ran, you just want to navigate these screens and see what they have to offer and how it can be improved, you can actually do that as well. I can pass the public URL that we just discussed. So as you can see, we just checking out the service and the front end is available here. It's basically it is available over a load balancer. This being EKS, we figured that might be a simpler option for us to use. So let me just this is because of the Emacs. So let me get a clear view of the load balancer URL. Yes, this is the one. So you can actually use this. Meet chat. I'm posting it on the session chat. You can use this URL and use a view admin whose details are available here. This is the username. This is the user who also has the same username and password. And you can use this to sort of take a look at the portal and share your feedback. The portal is under continuous improvements right now and is in the beta 1 stage and is expected to go GA in a couple of releases as part of the Litmus 2.0 release. So feel free to take a look at that, and you can reach us out on the Bootcamp Kafka Slack. Yeah, we've got a question there. What is the expectation for the V 1.13 release of the Litmus portal? That's a great question. We have some folks here who can actually take that. I think we have Raj and Shomo. Would you like to take that question, Raj or Shomo? You can raise your hand and I can sort of bring you on the stage. Yeah, the admin and the functionality is also open source. Yes. The admin service account is something that you can find, Alexander, here in the Litmus pages. This is basically a website where the manifests are being stored. You can basically take a look at the admin RBAC YAML here, and you can also use the Helm chart for Litmus, which you will obtain in Litmus Helm. that's something you can take as well. So yeah. The instructions for installation of the portal and all the other steps are mentioned here in the portal folder of the Litmus repository, and there is also a user guide that you can take a look at, which helps you with other capabilities of Litmus. Just to come back to Darren's question against expectations for 1.3 release of the portal is you will have ability to remove the workflows. I think someone asked that earlier during the session. You will have the option to see more predefined workflows. So right now, the portal has fewer workflows here. You will actually be able to see more predefined workflows against sample applications like Sock Shop, for example, that will help you test out different experiments in a real world context rather than just killing a simple hello application pod or an Nginx pod. And you will also see access for private repositories. So you can actually not only provide public repositories here, if you've constructed your own experiments and you've pushed that to your private repos, you can provide that link here. You can generate an access token and put it on your repo, and you get all the experiments here. And you will also have the option to basically remove hubs or modify them, essentially the CRUD operations on the Chaos hubs as well as workflows. And there have been a few other enhancements on the setup of the targets, and also with respect to the analytics that you're seeing. Eventually, the roadmap for the portal, which might come in a 1.13.x patch. So typically we have a release that happens on the 15th of every month. But we also have patch releases that sort of goes out on demand between the 15th, from this 15th to next 15th. There are sometimes multiple patch releases that go out. So you will see integrated monitoring, which is a feature that's coming up in Litmus, where you can, whatever interleaving or the chaos interleave dashboards that you saw on Grafana is something that you can also see on the on your portal as well. So that's an interesting feature. And then you will have the capability for GitOps, syncing the Git workflows on your Git source with your hub. So whenever you make changes there, they get synced to your portal DB. And also event triggered chaos, where there will be an event tracker running on your cluster, which will send a request to your Litmus portal to trigger a workflow upon certain specific changes made to your application on the cluster, either by Argo CD or Flux or Keel or any such GitOps controllers. I think that's what you can expect in 1.13 and beyond. Okay, Alexander has a rather interesting question. He asks how many engineers from Chaos Native are continuously working on the portal and Litmus development. It's being open source. I think Chaos Native is formed just a couple of days back. We were part of an organization called Maya Data before that, where the focus has been on two open source projects. One is OpenEBS, it is a containerized storage project, and the other one is Litmus. So we have about 3 to 4 folks working on the Litmus platform. That's the backend, the chaos operator, the experiments, and the portal backend. And then we've got a few more folks that have contributed to the front end. But there have been a lot of contributions pouring in, mainly on the orchestration and experiment side from the community, as you might have gauged from the different sessions and from the repository. So yeah, I think that's the answer. Thanks, Anujit, for the feedback. Do feel free to post more uh, issues. You might have different issues or enhancement requests against the portal, and it's timely that we open the issues. There is one that's there will be an event log added to the portal eventually to sort of help with audit to see what's happening on your portal, um, and what are the various actions that have been performed there, just to help you get improved observability. Feel free to create an issue here for any enhancements or feature requests or bugs that you find you come across the portal. There is a bootcamp that's going to happen tomorrow, which is similar in nature, but that's going to be on a Percona ExtraDB cluster with a different use case. So do join us if you'd like to look at other capabilities of the portal and Litmus. We will be using some probes there. We will be using some KTS probes and other hypothesis, other declarative definition for hypothesis in tomorrow's sessions. If you've attended Vadim's session today on chaos on databases, you might have noticed some interesting use cases around how you can create chaos on databases, how you can inject network loss, and what happens inside of the Percona cluster. So we will be demonstrating that in tomorrow's bootcamp. So do join, and there is a Slack channel for that session as well called Bootcamp Percona. So you can join there and ask questions. There's some more questions by Alexander. Do we have a roadmap for portal written somewhere? That's a great question. We do have a general roadmap which is available on the Litmus repo for the overall project. The individual portal roadmap itself is mostly being tracked as issues today and not, okay, sorry, I've come to the wrong page. Yeah, this is the roadmap. So we have a general roadmap here, and there is some roadmap specifically for the portal that will get added as part of Litmus 2.0. So yes, we will definitely get back, update that portal roadmap as well. It will be published on the same page on the Litmus repo, Alexander. That should come in a couple of days. All right. Okay, so I suppose we don't have any other questions. Thanks, Rahul. Thanks everyone for staying on and asking great questions and giving us the opportunity to demonstrate the portal. And I hope you're enjoying the Carnival till now. Hope that you continue to join the other sessions. There's some very interesting talks coming up today and tomorrow. So, and we are always available on Slack for any questions that you might have. So I think we're good to end this session. In case you want to try out the portal or the experiments, do reach out to Udit or Shubham on the Slack, and we will help you with the environments. Thanks everyone. Have a great day ahead. I think we will be ending the session now.